In pre-calculus 30, radical functions are an important type of function for us to study. And chapter 2 is entitled Radical Functions. 2.1 is we're talking about radical functions and their transformations. So the transformations, we spent all chapter 1 talking about transformations, right? We transformed lines, we transformed a lot of parabolas. What you're going to find throughout the first few chapters of this course is that we're going to be transforming lots of different kinds of functions. So this is just another kind of function that we're going to be working on, transformations. Really, chapter 2 is not much different than chapter 1. It really isn't. If you understood chapter 1, then chapter 2 is going to be pretty easy because a lot of the same parameters are going to be used. So when you see transformations, we're talking about, slides, slide left, slide right, or a slide up or down. We're also talking about stretches, horizontal stretches, vertical stretches. Okay, so that's what transformations are. A radical function. So you guys remember, hopefully you remember, from pre-calculus 20 what a radical is. Okay, a radical has some kind of square root or cube root or fourth root, some kind of root in the equation. So this is a radical right here. And if we're talking about a radical function, we have y equals the square root or cube root or something of x, or of 2x, or of x plus 1 or something. So there's a radical in the equation. So we're going to look at a table of values for this graph. We're going to look at graphing these functions using the transformations. And we're also going to talk a little bit about domain and range in this lesson. So that's kind of where we're headed. My question to you is, how are the functions y equal x squared and y equals square root of x related? How are they related? Do you remember from chapter 1 what the relationship might be? Inverse. Yes, inverse. That's what that word means, okay? One is the inverse. But if you were to take x and y and reverse them, remember inverse means reverse. So if we had this y equals x squared, and I exchange these or reverse these around and did this, okay, how would I get y all by itself? Well, I would take the square root of both sides. Now technically this would make y equals plus or minus the square root of x, which is totally true. But if we're talking about the function part, we only choose one of these, the positive version or the negative version. So you guys might remember now, if we know that this is an inverse, right? They're inversely related. You know what a parabola looks like. Looks like this. And you know what the inverse of a parabola looks like as well, right? Here's y equals x. So guess what? Invariant point, reflection, right? Reflection here, reflection over here, right? And so on. So you've got this sort of thing happening. This is the y equals positive root x version right here. And this is the y equals negative root x version right here. So if we look at y equals x squared and y equals square root of x, they are inverses and their graphs kind of look something like this. Okay, so there's y equals x squared, and here's y equals square root of x. So what we're going to do is we're going to explore this kind of rough-looking graph here. We're going to explore this a little bit more by using a table of values. But let's just officially kind of look at this definition for what a radical function is. So a radical function, and this is as defined in your textbook, is a function that involves a radical with a variable, more specifically in the radicand. So to be more specific, it's not just a root sign, it's the variable, the input variable is in that root sign somewhere. It's underneath the root sign somewhere. If we didn't have the variable there, and we just had y equals x plus square root of 5, this is not a radical function, because this is just a constant, right? So this would just be some line like this. Okay, not a radical function. Radical functions have this sort of shape, all right, because they're inverses of some sort of parabola. Any questions so far? So here are some examples down here. Root 3x, also y equals 4 times the cube root of 5 plus x. So notice x is underneath the radical sign. And we can have square roots or cube roots or whatever other kind of roots. Okay? All right, so let's look at a table of values here. Let's do that. Let's do x and y for the function y equals square root of x. All right. Now, what about x equals, let's see, -4? Okay, what about x equals -4? What if that's the input value? What is the output value here? What's the y? What's the square root of -4? Nothing? 0? Sorry? Nothing? Okay. Are we confused? Do you see a problem with this input variable? What's the problem? It's a negative, right? And so the problem is that if you take the square root of a -4, your calculator is going to be upset with you. It's going to say error or some other kind of message saying, what do you think you're doing? We can't do this. Now, the fact is that there is a mathematical answer for this, but it's a complex answer. That means it involves an imaginary unit, if you can believe it. Math is like the most concrete subject in the world. But yet there are imaginary parts of certain types of math. Isn't that cool? I think that is amazing. So there is no real solution to this, okay? It is not real. It is totally unreal, man. Okay? So we can't graph it. Not on a real coordinate plane, because only real numbers can go on this plane. So that's right. So that's an issue. Now, it makes sense if you look at this graph up here, right? It makes sense how on this graph, the red graph, which I just outlined in green, I don't know why, but the red graph here, there's nothing over here in the negative x domain, right? There's nothing over there because it doesn't exist there. So we can actually talk about a domain for y equals the square root of x. What's the domain for y equals square root of x? It has to be x values that are what? Greater than or equal to 0. That's right. See, it starts at 0. It cannot have negative numbers. And this is why. If you plug a negative number under the square root, you have an issue. Okay, so let's start with 0 then. What's the square root of 0? See, this is literally what we're doing. We're trying to find y when I put 0 in for x. Well, square root of 0 is 0. Very good. So, I'll do this in black now. There's your first point. Let's just do this official 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? All right, let's do that. All right, so what about 1? If I have x equals 1, what's the square root of 1? 1. Very good. So we have a point that is... Okay, so I'm just going to go to 10 up there as well. So we have a point that's 1, 1. Awesome. Okay, what about... what about 2? First of all, is there a y value that goes with 2? Like, does that make sense? The square root of 2, is that okay to have a y value that's the square root of 2? Yeah, that's allowed, totally. It's not like an integer number, right? It's not a whole number. But what's the square root of 2? Well, if you want to write a decimal, you can. We'll write root 2 here, okay? But what does that actually equal? Well, yeah, 1.4. So the square root, square root of 2 is 1.414. So that's the same as 1.414. And so if you go over 2, the square root is something like right about here. Okay. So we did 1, we did 2. Now, what's the next friendly number, the next friendly input number that I should use here? Yeah, 4. Very good. Why would you use 4? Well, what's the square root of 4? It is 2. So we're going to go x value of 4, y value of 2. Right about there. Okay? So do you see how these dots are sort of starting to line up with this, roughly? It's not a very good drawing up there, but okay? So what's the next sort of friendly number I should use for an input value to get a whole number? 9. Yeah, and that square root is 3. So we'll go 9 and we'll go 3. Right? So if you carefully connect these dots here with a nice smooth curve, you get something that looks sort of like this, right? Okay. So that's the graph of the square root of x. the input value, and you take the square root of it to get y. Other friendly ones we could put in here, 16 and 4, 25 and 5, 36 and 6, 49 and 7, and so on. Right? Those ones are nice friendly numbers to graph. Now, I'm going to, do you have a question about that? Okay, I'm going to pop over to Desmos here. Good old Desmos, one of my friends. Here is, boom, the square root of x graph. Look at that. Now, wasn't that a whole lot easier than us going through the hassle of the table of values? You know what I say? Too bad, so sad. Deal with it. You have to be able to understand kind of where those values come from. So yes, it's easy to graph, and on your graphing calculators that you have in front of you right now, you can graph this as well. So go ahead and do that. Y equals, get your y equals screen there, clear everything else that's on there. Second function here, y is square root, and then just put an x right there, and then graph it. Now your scale might be a little wonky like mine is because I had another graph going there. What you could do is just do zoom 6 to get to a standard window, and you kind of see it looks something like that. Okay? So if you adjust your window a little bit, you could see it like it is on the screen here, but I'm just saying that there you go. You can pretty easily just pump it into your calculated square root of x. Okay? All right, so we can totally use the graphing calculator. I'm going to use this because I have some things set up here where we're going to talk about transformations. Okay? Talk about transformations. Now, what's the kind of the easiest transformation here that we could apply? And now I've got this. I'm just going to like take this. Oh, you know what? You've already seen it, but that's okay. Let me leave a little space so we can kind of develop this a bit. But all of the same transformations can be applied to this radical function. So you guys have probably already stepped ahead of me anyways. But we could translate this whole graph left or right, or up or down, right? And so that has to do with this parameter. Now remember that this h has to be underneath the radical sign with the x, okay? If it's not underneath the radical sign, then it's really the k, because that's the k over here, okay? So y equals square root of x minus h plus k. So that's the big thing, transformation. This is a left-right transformation. This is an up-down transformation, or a translation. Got it? Desmos over here. Okay, so where are we? Let's use this one here. So there's our root x. I'll leave that there. So I'm going to get this one lit up here. There we go. So it's right now, the parameters are set to a equals 1, b equals 1, k is 0, h is 0. That really means that we have y equals square root of x. That's it. So it's the same. And if I move k, let's do h first. If h is a positive, let's say, I don't know, 3, that's going to be x minus 3 in there, right? So look what happens when I change this parameter. See that? And as you would expect, the whole graph is moving to the right. So if h is 3, that's x minus a positive 3, x minus 3. Moves it to the right 3 units. Now what's a little bit funny is over here it looks like, hey, it looks like this is nicely separated, but it looks like it's not drawn properly over here because it's quite close together here, the graphs. Well, you know what you have to remember, this is super important, so watch this. This is a separation of 3 units. Every y value, okay, is going to remain the same. It's the x values that are going to move, see? So right here, this dot right here, what point is that? Okay, that should be 4, 2. And so the one that corresponds to it is over here at 7, 2. Where was it? Boom. See that? So same distance. Over here, 10 and 3.1 or so. Okay, if you go straight over horizontally, okay, you still go 3 units. So the 10 to 13 would be over here. See? 10, and you go over here to 13, which has the same y value. See? So because of the shape, they look like they're getting together, but you're looking at this distance right here. You're not looking at this distance, see? So it fools you a little bit, but this is totally right. Okay. All right. Any questions so far? Okay, so let's make h1 again, or I'm sorry, 0 again. Make h 0, and we're going to move k now. So what's going to happen if I increase k? What do you think? It's going to go up, right? Let's just see if you're right. Oh, everyone's holding their breath now. Oh, look at that. Slides up. Okay. So there's k equals 4. Look at this. What once was 0 is now 4. What once was 4 is now, I'm sorry, what once was 2, here we go, 2 is now 6. See that? Up 4 units. Any questions there? Okay, watch this. So we're going to take this back to 0, and I'm going to play, sort of. There you go. So it's going up 10 to 10 there. Let me just zoom, what am I doing? Zoom out a bit. Okay. And of course, when h is played as well, see, goes left, right. Everyone see that? All right. Okay. Awesome. Stop. Thank you. All right. So that's 0. That's 0. So that's the horizontal translations, right? So there we go. Now, if we were going to write the vertical, or I'm sorry, the vertical stretch and the horizontal stretch, that's going to be your a values again, right? Okay. So it's going to look like this. Sorry, the vertical and horizontal stretch are going to look like this. Now, do I have this one rigged up here? Yeah, I do. Okay, so let's just look at these parameters just on their own. So let's get rid of that one. All right, we'll light up this one. Not sure why this is working well. Okay, there we go. All right, so we've got both of these graphs on here right now. So let's just take a look at A. If A increases, now watch this carefully. It's not going to be a shift. It's going to be a stretch. Right? Okay, a stretch of 3. Now I'm going to zoom in a little bit here. Yeah, okay. So how do you know if this is a vertical stretch or a horizontal compression? Right? Because really, they kind of look similar, don't they? If this red graph was compressed in like this to form this one, it would look very similar, and I'm going to show you that in a bit, because that's B is the horizontal compression. But if you look at the y values, right? Like, for example, here's y of 2, okay? And A is 3, so look at 2 to 6. You see that? It's times 3. If we took a look at this point exactly, okay, it's about, that's 1.4, okay, and this point here is about 4.2, so that's times 3 as well, okay. So every point vertically has been multiplied, the y value is multiplied by 3. Now what I'm saying with the b value, and if I just light up the b value here, if I make the b value greater as well, look what happens. You see how it looks very, very similar? You see that? Looks quite similar, doesn't it? But let's say we have b equals 4. Okay. B equals 4. And I have a equals 4. Are they going to be the same? Not at all. See, the red is the original function. And what you want to do is you want to go like this, okay? So the orange one here is where b is 4. So let's say if we have x equals 16, look at this one. This is x equals 4. That's exactly 1 over 4. See that? So each point here has been divided by 4. What's this? 8. Okay? If you go straight across, boom, that's at 2. See? 8 to 2. So divided by 4. That's the x values divided by 4 here. You have a b value of 4. If you have this blue one here, you have 4. You have this red one being multiplied by 4. So look at this. The y values, 2 times 4 should be 8. You see that? So they're not the same at all, although they kind of can look the same, I suppose. What do I have to do? Okay, if I make this pretty large, oh, I don't have enough jam for it here. So let's see, if I made this one a little bit lower, you could get them to look pretty close to being the same. See that? Are they the same? We could probably figure it out mathematically, couldn't we? 2.2, 4.8. If you put an x value in here, what's the y value? If you put an x value in here, what's the y value? So you could figure out if these are exactly the same probability or same functions because it looks like it. Okay. So I say we do that. Just hang on to your question, okay? So let's go back here. So what is it again? Y equals 2.2 root x and 4.8 is the other one. Okay. So check this out. Y equals 2.2 root x and y equals square root of 4.8x. Those graphs look really, really similar. So why don't you just take a half a minute here right now and make a quick table of values here and see if they are the same. Okay, just do a couple points each or whatever. So see if these are the same, because on the graph, it looks like they are the same. You see how I move it away there and move it back? Okay, so 2.2 appears to be the same. Okay, so go ahead and take a minute, just do that. So you guys get the same values here? It doesn't look like the two are exactly the same because these y values you see aren't the same. So on the calculator here, with the first graph I got 3.11126. This one is 3.098. So pretty close, but these are just a little bit off too. Now, we could try and change this parameter a little bit. We could maybe, I don't know, what could we do here? We could add something here. We could do x maybe minus 0.1 or something, or 0.01. I don't know. We could maybe change these parameters to get them pretty close to be exact. But I guess the bottom line is you have to be careful when you're looking at transformations. You do have to kind of consider, is this a multiple from here to here? Or is this a multiple from here to here? Is that consistent? Is it consistent horizontal translation from here straight over to here? Or is it a consistent vertical, I guess, a stretch? See? All right. So here you go. Make sure you have this written down right here. Y equals a root b bracket x minus h bracket and plus k on the outside. So it's the same parameters as for any others. And I do want to talk just briefly about domain and range. We have talked about domain a little bit, but what you see, I'll just get this written down here real quick, and then I'm going to pop back to Desmos here. And what you see that the domain is definitely restricted here, right? And what is it that affects the domain? Well, let's just take that off, and that off. So what is it that affects the domain and range? Well, what does this k do? That affects what? That's vertical translation. So what is that affecting? Is that affecting domain or range? Range. Okay. All right. So what about this one? That's affecting what? The horizontal movement, that's affecting the domain, right? Okay. So with y equals x square root of x, just y equals square root of x, we have a domain of all real numbers. Or do we? No, we have a domain of x is greater than or equal to 0. If we move h, that domain changes. See that? So if h is negative 2, guess what? The domain is x is now greater than or equal to negative 2. So h affects the domain, and the domain basically, well, I don't want to make any blanket rules, but you have to examine what h is to look at the domain. The other thing you got to do is examine what k is to determine the range. So generally, if there's no flips or things like that, there's no vertical flips, then really the k value is directly related to the range. So right now, the range before, when this was 0, is y is greater than or equal to what? 0. Now if I move this k value, now it's y is greater than or equal to whatever k is. Y is greater than or equal to 5 for the range. Okay? And of course, if we move both of these around, now the domain starts here. and is greater than, and the range starts here and is greater than. Okay? Yep. Question? Yep. Yeah. So what your question is it's positive when it's just the mother function, right? The mother function here is just y equals x squared. Get that to 0. So just like this, right? If it's translated down, it's no problem if this has a negative value in y, or if it's translated left, it's no problem if it has a negative value in x. And I'll show you why that's okay algebraically. All right? So look at this. If we have y equals the square root of x, x cannot be negative here, right? That presents a mathematical problem. So x has to be greater than or equal to 0. That's our domain. If you have something like this where h is altered, like x, let's say minus 2, right? Now do you see how x is not just greater than or equal to 0 anymore? So what you do is you say x minus 2 has to be greater than or equal to 0. And then you solve for x. X has to be greater than or equal to positive 2 now. So there's your domain change. So whatever's underneath the radical sign, you set that to be greater than or equal to 0 and then solve for x, and that's your domain. Okay? So I'll say that once more. To solve for the domain, all you have to do is let what's underneath the root sign, set it greater than or equal to 0, and solve for your x. The only thing you got to remember, guys, is if you multiply or divide by a negative number when you're dealing with inequalities, do you remember what happens? The sign flips. That's right. Okay? The sign flips. So I won't maybe get too much into that, but I'll just say again what I said. To find the domain here, you know that this cannot be negative. So set it equal greater than or equal to 0, and then solve for your x value. All right. So that'll be the lesson for today. And I would direct you just before we close up shop here, and that's the bell. I just want to direct you here to the key ideas, which are going to come up soon, right here. The key ideas, and I will give you a couple questions to work on, probably 1 or 2 just to work on for tonight, so that we're ready to go for tomorrow. Okay, so that's the key ideas. Read over those. That's a summary of what we just did today.